All right, good afternoon and welcome to Master Talker online class. Today we'll be talking about a limit of a function, but you need to know this important values. That 0 divided by any number is 0, but any number divided by 0 is infinity. If it is plus, that number is positive, it will be positive. If that number is negative, it will be negative. Now 0 over infinity, like they crossed this way. Okay, 0 over infinity, infinity is now down. 0 over infinity is 0, but if infinity is up over 0, it becomes infinity. Okay, so this one, any number over infinity is 0. Infinity over any number is infinity. Okay, so instead of knowing this C, know this E and D. Forget about C and D. Just know that any number over infinity, if infinity is at the denominator, that the answer is 0. But if infinity is at the numerator, the answer is infinity. Okay, then infinity plus infinity is infinity. Infinity times infinity is infinity. Then infinity times negative infinity. Remember that plus minus is minus. Then infinity times infinity is infinity. Okay, 0 over 0, infinity over infinity, and infinity minus infinity are all indeterminate. Okay, we cannot determine it indeterminate. So from here, let us now solve some questions on limit. Now, limit of a function is simply, do I just call it substitute? I don't want to start telling you long stories, okay? Just substitute. If I have that, they say evaluate the limit of x tending to 2 of x squared plus 1, okay? So how do you read this thing? The limit of x squared plus 1 as x tends to 2 or as x approaches 2. Okay, the answer is simply just substitute anywhere you see x, put 2. The answer is simply 2 squared plus 1, which is what? 4 plus 1, which is what? 5. As simple as that. Okay, so number 2, we'll solve so many questions here. Number 2, they say the limit of 5x cubed, okay, minus 2x plus 3 as x approaches 6. As simple as that. So my answer is still 5 bracket 6 all raised to power 3 minus 2 bracket 6 plus 3. So what do we have? 5 bracket okay, just do everything, you have a 1071. Okay, so just do everything, you have 1071. So this is number 2. So number 3 said the limit of x raised to power 3 plus x raised to power 6 minus 1 all over x squared plus 1, okay, as x approaches 3. Okay, so let us do that. Just substitute. So my answer is what? 3 raised to power 3 plus 3 raised to power 6 minus 1 all over 3 raised to power 2 plus 1. So what do we have? The numerator is going to give us 755 divided by 10. So my answer is what? 75.5. Okay, so that is that. So let's continue. Now they said if f of x, number 4, okay, they said if f of x is equal to 2x, okay, then I said the x naught is equal to 1, okay, then I say find the limit of that f of x as x approaches that x naught. Okay, solution. It means that what? The limit of what is my f of x is what? 2x. As s approaches what? x0 is what? 1. So my answer is what? 2 bracket 1, which is what? 2. Okay, it's very, very simple. Number what now? Number 5. Number 5 says evaluate x squared minus x minus 6 over x minus 3 as x approaches 3. Okay, now if you look at this now, what do you do? Let us solve. Solution. Sorry, the limit of this. The limit of this as x approaches this. So let's evaluate that. Okay, so this means that the limit of what? X squared minus x minus 6 all over x minus 3 as s approaches 3. Now if you look at this, if you substitute 3 here, you have what? 3 minus 3 is what? 0. If you put 3 here, you have what? 3 squared. Okay, let's just put it. This is equal to 3 squared minus 3 minus 6 all over 3 minus 3. You see that you are getting 0 over 0. Okay, it doesn't work. So what do? The limit of x squared minus x minus 6 all over x minus 3. Now if you look at the numerator or denominator, anyone that is factorizable, factorize it. Now if you factorize this thing by quadratic equation, how do you factorize quadratic equation? I have x squared minus x minus 6. So the two things to replace this is minus 3 minus 2. So I have x squared minus 3 minus x squared minus 3x minus 2x minus 6. Okay, so what do we have? We have x minus 3, x minus 3 minus 2 and x. So I have x minus 3 and x minus 2. Okay, if you factorize that. So if you don't know how to do factorization, so go to my video on quadratic equation. So I have this. So this means the limit of x approaching 3 of, instead of writing this one, I'm now writing x minus 3 and what? And x minus 2 all over x minus 3. If you look at this now, you see that this is taking care of this. So my answer becomes the limit of what? X minus 2 is remaining as what? As x approaches 3. So which is what? 3 minus 2, which is a 1. Okay, as simple as that. So anyone that is factorizable, you factorize it before you solve. Okay, so all right, number 6. Number 6 said that we should evaluate the limit as x approaches 5 of 3x minus 5 all over x squared minus 3x minus 10. Okay, so that is that. So what do? First of all, let us substitute. I'm going to have solution. So the limit as x approaches 5 of 3x minus 5 all over x squared minus 3x minus 10. Okay, so let us substitute. I'm going to have this is equal to 3 brackets 5, okay, minus 5 all over, anywhere I see x, I'm putting this 5, okay, all over what? 5 squared minus 3 bracket 5 minus 10. So what do we have now? Numerator is giving me 3 times 5, 15 minus this, I'm having 10 all over. Denominator is giving me 0. 25 minus 25 is 0. Now 10 divided by 0, what do you have? Infinity. So an infinity is not a real number. I hope you know that infinity is not an element of a real number. So what does it mean? That the limit of this function exists. Okay, the limit exists, but it does not exist in the real. The limit exists, the limit is infinity, but it does not exist in the real. But the other one we did, if you have 0 over infinity, if you have 0 over 0, it's indeterminate, but there's another solution to it. Okay, but this one is that the limit exists at infinity, it does not exist in the real. Please note that. Okay, so the next one we are going to solve number, where are we? Okay, all right. So they say determine or evaluate. They said evaluate 2x raised to the power 3 minus 5x raised to the power 2 minus 3 all over 5x raised to the power 4 minus 4x raised to the power 3 plus x plus 1. evaluate the limit, the limit of this as x tend to infinity. Okay, so we want to evaluate this whenever your x tends to infinity. Whenever your x tends to infinity, look at the method, please. Don't go and substitute infinity immediately. The method is what? Divide each of the terms, okay? Divide each of the terms by the highest power of x. In fact, the answer is always the highest power of x, okay? The answer is always what? The coefficient of the highest power of x is always like that. So let us try that. Okay. So if the shortcut to this, the highest power of x is what? 4. And here the highest power of x here is what? 3. But I can put 4 here. So the coefficient of 4 here, x raised power 4 here is 0. And the coefficient of x raised power 4 here is what? 5. So 0 over 5 is what? Is this 0 or infinity? Is 0. So the limit is 0. But let us just solve it. How do you solve it? This is the limit of x tending to infinity of, watch me now, 2x raised to power 3 divided by x raised to power 4. Are you getting it? Minus 5x raised to power 2 divided by x raised to power 4 plus 3 over x raised to power 4. Everybody is dividing by what? 5x raised to power 4 over x raised to power 4 minus 4x raised to power 3 over x raised to power 4 plus x over x raised to power 4, then plus 1 over x raised to power 4. So if we do this, we are having what? The limit as x approaches infinity of this, and this is giving me 2 over x, okay, minus this, and this is giving me 5 over x squared, plus this is giving me 3 over x raised to power 4, okay, all divided by 5 minus 4 over x plus 1 over x raised to power 3 plus 1 over x raised to power what? X raised to power 4. Now, once you are done dividing with the highest power of x, okay, now you can substitute that infinity. If I substitute infinity, I'm having 2 over infinity minus 5 over infinity squared plus 3 over infinity raised to power 4, okay, all over 5 minus 4 over infinity plus 1 over infinity raised to power 3 plus what? 1 over infinity raised to power what? 4. Okay, so that is that. Now, don't forget that any number over infinity is what? Any number over infinity is infinity or 0. Don't forget, any number over infinity is 0. Remember, if the infinity is at the numerator, that is when it will become infinity, okay? But since infinity is at the denominator, it is 0. So I'm having what am I having here? 0 minus 0 plus 0 all over 5 minus 0 plus 0 plus 0, okay? So what am I having here? 0 over 5. And 0 over any number is what? 0. So that is that. You see that the shortcut to it is the highest power is x raised to power 4. And there is no x raised to power 4 here. So the coefficient of x raised to power 4 here is just 0. The coefficient of x raised to power 4 here is 5. So 0 over 5. And 0 over 5 is what? 0. So that is the shortcut to this thing I just did now. Okay? That is that. Okay, let's look at another question that deals with that infinity as well. Okay. Okay. Okay, look at this. Before that, let's take the limit of x squared minus 1 all over x minus 1 as x approaches 1. Okay, this is equal. If I put 1 here, I'm having 1 squared minus 1 all over 1 minus 1. So I'm having 0 over 0. But if you look at the numerator, the numerator is factorizable. So this is what? The limit of x approaching this of what? X squared minus 1. In fact, this is difference of 2 squared. X squared minus 1 squared all over x minus 1. So this is what? The limit of x approaching 1 of difference of 2 squared, x minus 1 and x plus 1 all over x minus 1. So you see, this will cancel this. So my answer becomes the limit as x approaches 1 of x plus 1. That is what is remaining. So what am I having now? 1 plus 1, which is what? 2. Okay, as simple as that. So the next one we're going to solve okay. Now another method of solving this is by using differentiation. If I have this, that is called L'Hospital's theorem. L'Hospital's theorem, okay. Alternatively said is using L'Hospital's. So using L'Hospital's theorem, when do we use L'Hospital's theorem? We use this whenever you have 0 over 0. That is when you apply that theorem. Watch me now. So now if I substitute, I'm having 1 squared minus 1 all over 1 minus 1, which is what? 0 over 0. So let us apply the law. Lim x approaching 1 of, now what do? You differentiate. Now this is supposed to be quotient rule, but we don't do it that way. Just differentiate up normally, differentiate down normally. So if I differentiate up, I'm having what? 2x. Differentiation of x squared is 2x. Differentiation of 1 is 0 all over. Differentiation of x is what? 1. Differentiation of 1 is 0. So I'm having the lim of, as x approaches 1, of 2x remaining. So which is what? 2 bracket 1, which is 2. So you see, we have the same answer. Okay. I can clean here. So the next thing we are going to look at is the lim of 3x squared plus 2x plus 1 all over 2x squared minus 1 as x approaches infinity. I told you that whenever x is approaching infinity, find the highest power of x here. And the highest power of x here is what? X squared. So just take their coefficient. The coefficient at the numerator is 3. The coefficient at the denominator is 2. And that is the answer, 3 over 2. Even if you solve it using the normal method, you will still get the same 3 over 2. Okay. So let us, you can try it yourself, okay? You can try it yourself. So look at another question. Another question now said we should take the lim, we should find the lim of x squared minus x minus 6 all over x minus 3 as x approaches 3. Now if you substitute this thing, you're having 3 squared minus 3 minus 6 all over 3 minus 3. You see, I'm having 0 over 0. And immediately you have 0 over 0, just apply L'Hospital's rule, which said what? Differentiate the numerator, then differentiate the denominator. So I'm having that this is the lim of x approaching 3 of, if you differentiate here, you're having what? 2x. Differentiate this one, you're having minus 1 all over. Differentiate this one, you're having 1. So this is now what? The lim of x approaching 3 of just 2x minus 1, which is what? 2 bracket what? 3 minus 1, which is equal to what? 6 minus 1, which is 5. Okay? As simple as that. So I don't think there's any other thing they can ask you on limit. Okay? I don't think there's any other thing they can ask you on limit. Okay? So that is that. Maybe I'll solve one question from trigonometry and know what we are going to have. So I have this. They say define the lim of sine x all over x as x approaches 0. So it's simple as saying what? Sine 0 over what? 0. And sine 0 is 0 over 0. You are adding 0 over 0. So what do? Apply L'Hospital's rule. So let's do that. The lim of x approaching 0 of differentiation of sine is what? Cos x. And differentiation of x is what? 1. So this is simply the lim of just cos x as x approaching 0. So what do we have? Cos 0. And what is cos 0? I think cos 0 is 1, right? Yes, cos 0 is 1. Okay, so that is that. The next one we're going to do, and that is the last question I'm going to solve here, is we should find the limb of sine 3x over sine 4x as x.
So what do we do? Sorry about that. I'm having sine 3 bracket 0 all over sine 4 bracket 0. So which is what?
So which is sine 0 over sine 0, which is 0 over 0. So it doesn't work. So we are going to apply L'Hospital's theorem. So which is what? The limb of x tending to 0 of. Now, differentiate 3 sine 3x will give you what? 3 cos 3x. I hope you still remember. This one will give you 4 cos 4x. So what do we have now? The limb of x approaching 0 of 3 cos 3 bracket 0 all over 4 cos 4 bracket 0. So what do we have now? This is the limb of x approaching 0 of 3. This time this is 0 because 0 is 1. 3 bracket 1 all over 4 bracket 1. So which is what? Sorry, we are not putting limb again because we have substituted. We are not putting limb again. So what do we have now? 3 over 4. And 3 over 4 is the answer. So thank you very much for watching. In our next video, we'll now talk about continuous function.